fission, nuclear decay, nuclear reactions. Presently, the vast majority of electricity from nuclear power that is produced by nuclear fission of uranium and plutonium, the nuclear power plants. So once uranium is used, it is gone. So it is called as non-renewable.
Good morning. Am I audible? Hello. Thank you. Thank you, sir. Thank you. So, my name is Dr. Amit Kumar, and I'm working as an associate professor in the Department of Electronics, Bhaskacharya College of Applied Sciences. And today I'm going to present a paper titled Comparative Study on Emerging Rooftop Photovoltaics for Urban Greenery. Basically, if we see, there are two technologies that have gained considerable attention for the environmental safety in recent times. One is green roof concept, which promises the energy conservation by improving the building thermal performance. And another one is integrating the photovoltaic system on the rooftops as a source of renewable energy for urban buildings. Limited roof space, however, makes these two technologies a competitor for each other. Emerging fact is that these two can be integrated to offer a more conducive environment-friendly solution. Evapotranspiration caused by the roof greenery further enable the higher efficiency for photovoltaic panel, and that in turn shades due to the panel protect plants from excessive sun heat and evaporation. So these are two complementary technologies that can improve the performance of one another. The mechanism that enable improvement, this mechanism enable the improvement of plant growth and efficient photovoltaic energy for the building. The initial studies were initially focused on evaluating the performance analysis for green roof and photovoltaic separately. But the beneficial integrated circuit are now gaining interest among the researchers and developers. The advantage of this emerging technology is pivotal for the subtropical countries like India, where we get the best of the sunlight exposure. This schematic shows the mechanism for green roof. Green roof for a building refers to the rooftop that is partially or completely covered by the plants, with the growing medium over the waterproof roof slabs. Outdoor climatic factors like solar radiation, temperature, humidity, wind flow, etc. improves the green roof. The solar energy gets absorbed that helps the growth of the plant due to improved photosynthesis and transpiration, evaporation and respiration. The internal benefit to the building lies on the fact that it reduces the roof surface temperature, that in turn decreases the energy requirement. The external benefit lies on the fact that it decreases the outdoor urban temperature indirectly and improving the surrounding environment. So the height, basically what are the limitations that photovoltaic panel have? The high temperature decreases the efficiency because of the increase in the carrier recombination rates. Due to the increase in carrier concentration, the productivity loss due to temperature increase is found to be as high as 25%. Therefore, heat is the primary concern for the roof-mounted photovoltaic panels. In fact, a linear dependence is found for the power loss and photovoltaic cell due to surface temperature increase. A typical solar cell converts 6 to 20% of the incident solar energy to the electricity, and rest goes away as a heat. Another deteriorating fact is air pollution that causes dust to get mounted on the PV module surface and partially block the sunlight, hence results in reduced output. A significant impact on the PV efficiency is found to be as high as 20% due to air pollutant. However, such performance depends upon the atmospheric conditions and cannot be generalized. This schematic shows the integrated rooftop for the photovoltaic panels. The integrated technology for green photovoltaic, that is, combining green rooftops and solar photovoltaic, initially reported by Kohler et al. An initial idea was appreciated due to promising result as good as 6% higher than the conventional roofs. The green ambient around the solar PV panels creates cooler atmosphere at the reduced dust levels so that it works better. Advantage to the integrated green roof is that it can reduce the ambient temperature between 0.3 degrees Celsius to 3 degrees Celsius based on the regional climatic conditions and type of vegetation used. The enhancement performance of photovoltaic output increased efficiency up to 3% by green roof photovoltaic that has already been reported. There are other methods. Basically, what are the different mechanisms that are used for PV surface cooling? Liquid-based cooling mechanism may be subdivided into active and passive systems depending on whether we use the pumping system or not. Arrow-based methods are also there. It can be natural without the use of fan, or it could be forced with the use of fan and blower. Use of extended surfaces such as fins, heat sink can also help in reducing the temperature furthermore, depending upon the material and configurations. If you see, the passive cooling is easy, economical and active, and because it does not require the pumping system. And generally used liquid for the PV panel is water due to its economical price and good thermal conductivity and better heat capacity. Some groups, however, added nanoparticles to the water to obtain improved results. Active cooling procedures. In active cooling procedure, high water flow velocity improves the convection process and results in better cooling. The running cost of overall system, however, increases due to additional power demand. Saxena et al. Reported the passive cooling with the various mass flows, and it is found that the energy output performance was found to be enhanced by as good as 18% as compared to uncooled systems. If a continuous steady flow rate is maintained at 0.6 liter per minute, then 25% power could be increased. Tashaw et al. Proposed the active cooling pumping by using pump, pipeline, sprinkle and nozzles, etc. The different positions were investigated and experimentally an observation showed that the cooling procedure gives efficient performance compared to uncooled photovoltaic panel with the best reported results at 37 degrees Celsius. However, the use of controller-based PV cooling system is now being investigated by various groups. Even though the active cooling method for PV module gives the better efficiency, but the cost is higher as compared to passive one. This is due to the requirement of pump and continuous monitoring of the system that in turn also consumes power. The current literature indicates that many cooling methods based on embedded controller that are being investigated for the enhanced output from the PV module. So these are some results which have been reported by various groups, and they have used the different controllers to find to make a PV cooling system, active PV cooling system, by using the controller, and thereby they are basically trying to automate the things and reduce the cost, thereby reduce the cost which is spent on monitoring the systems, on active systems. Here we are proposing a prototype for the active cooling system, because we are proposing the Arduino based board can be utilized for automated cooling system for PV module. It is open source hardware system that is powered by open source software that does not need any external programmer. IDE, that is Integrated Development Environment software, is compatible for most of the operating systems. Embedded system board does not require external programmer for burning procedures. These are some of the advantages for Arduino based system, and it is found to be compatible with IoT applications. But a more elaborated system was presented by Futes, and it is costing at about $73. So a simplified schematic for the automated cooling system is proposed in this work and PV module by using Arduino embedded controller that may be extended for the irrigation purposes also and for rooftop. Yes, sir. Yes, sir, it's coming. It is my this is the proposal. So what we can do is we can simplify the things, and we can use a pump and Arduino, and then we can computerize. We can program the Arduino by using computer programming, and we can use a data logger and SD card based on SD card to monitor the overall system. We can use various sensors to monitor the performance of cooling systems like voltage, temperature, and current, etc. The data is fed to the controller board, which is programmed to monitor and control the system. The relay switch is used. This relay switch is used to provide the control for the DC water pump, and that sprinkle the water on the surface of the PV module. That will reduce the surface temperature. The output. Okay. So basically, what we are doing here, we are proposing the simple module, a simple mechanism for controlling the photovoltaic temperature. And in this temperature, what we'll be doing is we'll be also using a data logger to monitor various parameters which can be controlled and monitored by this computer program. The elaborated design and economical solution, it will be an economical solution for the efficient use of rooftop photovoltaic for the greenery. Rooftop photovoltaic greenery. So basically, it is a working paper where we search for the problem and propose the solutions. We are working towards designing of this module, and we will be then enhancing its performance. So it is only a proposal up till now. We haven't realized it up till now, but we will be working on this. So conclusion is that rapid urbanization has depleted the green regions that needs to be balanced with the alternatives. This paper presented the importance of emerging. Yes, sir. Yes, sir. I agree, sir. But the thing is, this paper is basically aimed to collect the facts and then get the recent problems, and then the work will be carried out. It is a working problem. I am PhD from Delhi University. Yes, sir. 2006. Area, basically I obtained my PhD in material science, but now, yes sir, Professor P.K. Bhatnagar, sir. Yes, sir. Yes, sir. Yes, sir. We will be working on this problem, and we will be solving it. Thank you, sir.